Okay, so we're going to be talking about elastic computing and demonstrating with Amazon EC2. So, just a brief overview. Elastic computing is essentially utility computing. Instead of having dedicated machines, you pay for the resources required, like electricity, phone, and so on. So we will focus on EC2 in this presentation. There are some competitors coming up, but this still seems to be the most interesting one of them all, and the most flexible. We'll discuss the basics. Pete Skormovich talk, 131, which was early this morning, covered MPI clusters. And if you wanted to use EC2 for high-performance computing, we will cover typical data center applications. We will also cover basics of how to work with EC2. Ideally, you would have signed up for this already, quite a bit of familiarity, but you can still follow along even if you didn't do that. So, just before we have components, this whole rebirth of utility computing, virtualization is the thing that, cheap virtualization is really what makes it practical. EC2 actually uses Zen. What you can do is you can actually take UML, user mode Linux, split the Zen EC2s that you get into smaller virtual pieces, and use those, which is actually pretty neat. You can save yourself a bit of money this way. Most of the tools are familiar, SSH, Bash, Python, of course, but you can have a very different environment. A case in point is EC2 does not offer persistent storage for a file system. So you bring the virtual up, you can make all kinds of changes to it. If it crashes or you otherwise shut it down, that's the end of all your data. You have to make provisions of saving it. In other ways, we'll cover that briefly. Okay, the first thing is Firefox plugins. There's a couple that are very important. They're not essential. You can use command line tools, for example. But the EC2 UI and the S3 organizer are really very useful. Especially install the EC2 plugin just before you do anything else. You can start and stop machines from it, do all kinds of testing, because the security is a little tricky. Just a second. Security is a little tricky under EC2 when you first start out. It's easier to use this plugin tool, rather than starting to write Python programs right away. Okay, there are a few important things to note. EC2 allocates computation units on an hourly basis. Do not leave the machines running without need, because that quickly adds up. There's also bandwidth charges. These tend to be small. But if you run a stress test, you could, anything automated, that can wind up there. Just a thing to watch out for as you're experimenting. Traffic between machines inside EC2 and between S3 and EC2 internally. S3 is Amazon storage service, it's free, so you're welcome to play with that as much as you want. There's also storage charges for storing the Amazon machine images, which is actually what the image of what you put up. But these are typically not very significant. So we start with the basics, elementary security, the bottle library, very nice, very well documented library, and automated administration using Paramiko, which is an SSH tool in Python, SSH library.
Can you make the font bigger?
Oh, okay. Is that better? This is S5, by the way. It's very nice, but sometimes it is a little bit temperamental. As many of you know, this presentation system, very interesting one. You will need the AWS access key ID and the AWS secret access key. You can have the web services account link, and they'll be there. You'll also need to generate a key pair for SSH into the machine. You can do that from the EC2 plugin. And by default, for instance, Amazon AMIs that they supply are strictly key-based authentication for SSH. You definitely want to keep that because there's lots of attacks on port 22 and people will try to log in. So try to set up the EC2 plugin first because security can be a little problematic. You can start and stop machines. You can verify that you can start and stop machines there. So now we go on to the interesting stuff, which is the bottle library. They have a very nice tutorial, which we'll go over. Let me get this bigger. It is very, very straightforward to use. You can see this is, can everybody see this? Can everybody see this, or you want larger?
Larger, please.
Oops. That's a bit too big.
Nope.
How about that?
That's better.
Huh? Okay, so this is very well documented, so we're going to go over the official documentation, which is going to be maintained, which you're going to keep reading. Making connections, very easy. Watch out for this style of making connections. If you do any kind of unit test or anything like that and store your keys in there, somebody gets your keys, they can launch machines in your account, especially the secret keys to be guarded. So you can see there's several styles of making connections. Watch out, by the way, these connections cannot be shared between threads, although you can have a connection per thread, and that works fine. But don't try to share them between threads, or you will get all kinds of weird stuff happening. Images and instances. See, once again, when you got the connection, get all images. Straightforward enough. It lists all the all the images that is got available. So these are images, and you launch instances of images. That's what this is all about. You can see images that run, and off it goes. Now to do something, okay, this is state stuff. I'll just scroll by that for in a moment, just to get to something important. This is important. Generally, when you run images, you specify a key pair because otherwise you won't be able to SSH into it. Right? You can start without a key, but then there's no SSH access. So this person here started two, and they're both pending. More about pending and state of the system at the moment. You can stop them all. Obviously, you can get all the instances you're running. It's very thorough. I don't know if we'll have time to actually play with it and demonstrate it, but if people are interested, I'd be happy to come to open space and actually go through, sit with you for a while and actually play with this, to get you started. I'm losing my mouse here. Okay, let's get back. So as you see, it's pretty easy to use. Now, what we're going to talk about is automated system administration next, because now you've got these machines running. Now, what are you going to do with them? It's best to somehow automate. You're going to have multiple machines. It's best to somehow automate your operations with them. So what to do? Well, how about using SSH? SSH is good security. It's maintained. You're going to have SSH access anyways, so you're not opening up any extra holes. There was a Linux journal article on this topic. Okay, this sort of ran together, so these are two URLs. And also, let me get back here. Capistrano, which is a Ruby package, uses a similar technique. An interesting variation of the theme is actually to make Python, for instance, your root's login shell on these machines, or however you set up your administration, typically it's root, and then you can when you send the commands, you're actually going to send Python code rather than bash commands, if bash is the default, for example. So one important variant with Paramico, which is quite important when you're going to start doing this, you probably want the standard out and standard error to be merged together on the same output rather than dealing with them separately. And Paramico doesn't really seem to support that. So you subclass their client. Oops. Click here. By the way, is everybody seeing this okay? Nothing's interfering or? Okay, so this is the important thing. You override this exec command, and you combine the standard out and standard error, and then you use your subclass rather than the Paramico. This is here setting up policies, what happens when the host key is unknown, that it adds it. You can make it more sophisticated here. I mean, Paramico is extremely flexible. Not enough time, obviously, here to go into details of Paramico, but here you can do all kinds of complicated things. This is just the path. Obviously, you can make this configurable as well. Okay, establishing the SSH connection with this SSH client. Is just the host, the port, the user, and the name of the key that you're going to be using, and that's it. You're done. Sending a command string, if you want to do this non-interactively, is the vast majority of cases it does. Is again very straightforward. Here a bit of Python context management. With closing SSH, you get the input and output, execute the command, close the input, read the output, and you see all these good things. If you get an exception at any point, it will neatly shut itself down. Okay, a little bit of the design that we've been using, which might interest you. We've subdivided our stuff into fabrics, machines, and commands. So it's an approach for designing programs like controlling each facility. Fabrics, such as EC2, supply prototype machines, which basically define the addresses, the services it supplies. Instances of machine class, right now they're SSH-based, using Paramico, often using the factory. We'll then take these prototypes and generate you back an actual machine, which you can then send to command objects, which then actually executes stuff on the system. So that's a fairly neat separation because, for instance, you can take, you can make a fabric, like a fabric facade, which draws together several different fabrics and manage them inside. Like, for instance, if you got some stuff of your own and some in EC2, you can make it seamless with this kind of interfacing. Or once EC2 competitors come up, this is also useful. Some common problems is what to use for concurrency when you're managing these things. When is a machine really ready? That turns out to be a little complicated. And rolling your own AMIs, which you are going to want to do fairly soon. Concurrency model, the logic of actually configuring these things can get quite complicated. But the commands, like if you're configuring one machine, and if you're configuring multiple machines, like let's say you're starting several, the command streams run independently of each other, which is very handy, so there's no locking or anything like that. Also, it's very much network bound and very much beyond that determined by how long the target is going to take to execute the stuff you send it. So threads are actually very appealing here. We know that Python has the global interpreter lock, etc., but it's completely irrelevant in this case. You're going to spend so much time waiting for the host and for the network, it's not computationally intensive at all, to manage these. Using threads here is probably the most appropriate. There's very little locking needed between the threads because each machine tends to get configured separately. So this is the most appropriate choice. So when is the machine really ready? Well, it turns out you have to do this in two stages. As you saw before when I was showing you The Botto, the running state, you saw a little bit of that. It's only why I can go back to it if you want. So you have to ask Amazon EC2, is the machine ready? And Amazon EC2 will tell you whether it's pending, shutting down, etc. Once it's in the running state, it's not actually yet capable necessarily of doing anything. It might not finish booting yet. So try sending a command using parameco of your SSH, such as echo into dev null, and seeing if that blows up with an exception. And when it does not blow up with an exception, then you know that the machine is actually ready to do stuff. Now, this little innocuous little command, remember that because that's going to be important later. There's a little interesting caveat with that, which I will get towards the end. Your own AMIs. Rolling your own AMIs, that can get fairly tricky. Amazon does provide defaults. Oh no, crash. Oh well, doesn't affect anything. Self-bundling AMI has EC2 tools, EC2 bundle volume, EC2 upload bundle to create AMIs from running instance, and the upload saves into S3. So if you upload it, you then have to register it. You can do it through the EC2 plugin. And you can also deregister it and it stays in S3 until you delete it. So you can keep historical stuff around. It doesn't cost too much if you don't want to destroy it right away. These AMIs can get fairly large, in the multiple gigabytes range. If you want to build the Ubuntu AMI, which a lot of people seem to want to do, these are the links. There's actually the last link is actually a script. This will all be up on the web eventually. The actual link is actually a script which you can run on one of Amazon's standard instances, and it will do it for you. If you run it under Amazon's standard Fedora-based AMI instance, it will create a Ubuntu instance automatically, which is pretty handy. Okay, I'm going to talk a little advanced topics, cloudlets, I'll describe in a moment, storing system state, always important, and a very interesting idea from normal access theory. I don't know if anybody's familiar with that, I'll cover it a little bit. Okay, so first of all, we get to cloudlets. What we were thinking of doing is virtualization has actually gotten cheap enough now that you can support every single user on their own little virtual. So how do you talk about this? Well, we call it a cloudlet. It's basically a little piece of the cloud assigned to a specific user and following that user's needs. So that thing can move around. It can run under a virtual machine on a user's PC. It can run anywhere. In fact, Amazon itself is already doing this, because every time you start up a virtual machine, you just get a fresh one. You're responsible for setting up whatever state you want. There's actually an interesting file system, as an aside, called S3FS. It stores into S3, and you can mount it as a regular file system. Unfortunately, a couple of our people have experimented with it, and it's not quite yet stable. It crashes and deletes stuff after a while if you use it heavily. But it's a very interesting project, S3FS, which allows you to mount S3 buckets, as a regular file system, and that is very handy for storage. So hopefully that will completely stabilize. Now, under EC2, as I was talking about, implementing these cloudlets, you can do with EC2 instances, with EML instances, sorry, and you can also use UML instances for whatever else you like, whatever purpose. Basically what it means is that rather than paying 10 cents an hour for a machine, you can pay a fraction of that. We've managed to run 5 quite comfortably. Other people have reported, depending on the as much as 20. It all depends on what you're using it for. There is obviously a performance hit doing that. Nagafix.co.uk, excellent site for all things used in more Linux. Have plenty of file system images for you to play with that you can use with the system. The only thing is you will need to build your own UML kernels if you do that. Okay. You need to build your own UML kernels because the stock kernels don't work. When you build it, make sure the host memory split is set to 2 gig/2 gig, or it won't run under EC2. You have very little kernel control under EC2. You can build modules, but you can't patch the kernel. You can't change the kernel. Unless you build it this way, it will start running and it will fail in weird ways, and you'll wonder what's going on. So that's critical. Another idea with this is EC2 does take a while to start up. If you're running UML on top of it, it's going to take even longer to start up. If you're serving these little things to your users, you probably want to maintain a free list. And what you'll probably want to do is partially initialize it, stick it on a free list, and then complete the initialization when the user requests, service, and then deliver the machine to the user. Storing the system state, you might want to centralize, but consider distributing any state information to each actual AMI instance that you have running. You're going to have to have some monitoring of them. You're going to have some program to sweep them anyways. You're going to have to do that to monitor their state. You might as well keep all the information distributed and on the machine that it belongs to, rather than some central, because otherwise you'll wind up some state on the machine and some state inside your cluster management application, and it's easy to get synchronized. Now you can leave marker files. That's a very conventional Unix way of doing things. You can also use these as locks. If you can define a set of diagnostic commands, for example, if you're running UML instances underneath on this thing, then you can just check if the right processes are running to determine if they're around. If you can define commands like that, that's actually the best way because it's obviously the most difficult to get your state wrong. Marker files are vulnerable to damage if there's a problem in your logic. Now, a little bit about normal accident theory. We're hoping to talk a lot more about this at OSCON. We've submitted a proposal for that. Normal accident theory is something which, anybody familiar with this, by the way, normal accident theory? No, it's a classic work by Charles Perrow. It's been used to describe accident potential of diverse systems, from marine shipping to nuclear reactors, etc. It talks about, one key thing that it talks about is coupling and complexity, tightly coupled and complex systems. Tightly coupled and complex systems are prone to accidents. Accidents are inevitable in these kinds of systems if they run long enough. So if you think about even a small innocuous class, like something implementing the NOP operation we saw earlier, for checking if a machine is up, if you start calling it from many places, you can wind up inadvertently tightly coupling different parts of your program together. Then if you make a little change to that class, you can have a change that ripples through your entire program. You can use adapters and decorators to avoid this kind of problem. Instead of packing functionality into a class, you can use these instead, and build it up in layers. This becomes more critical in these kinds of distributed environments where there's a lot more complexity. You must sort of start paying attention to these kinds of techniques, whereas before it might have been okay to do without that. So I just want to thank all of our brilliant development team towards the end, and then we can answer questions. Heath Johns is my co-author, Formidable All-Around Intelligence. He unfortunately could not come. Tom Allison Taylor, our wonderful founders, deepest knowledge, absolute integrity, fantastic people. Aaron Vince, our genius mathematician, he builds siege weaponry on the side. Mike Edwards does remarkable work, even managed to get married while doing all of that stuff. Just Mike Michael, who can write any program in any language. He's also designing an electric car to blow Corvettes off the line. Stefan Karat, absolute expert in C++ networks, Linux infrastructure. Taylor Moore, he's a filmmaker, he's a director, he's an interface guru, etc., etc. Louis Blom, well, he keeps the comp running smoothly, but we have to include it because otherwise he can drink us under the table and he can beat us up, and he would do that, so we have to. Okay, and now we can open this up to questions. That's, yeah, for compiling the UML kernel, yes, you need that. It seems that this is dealing. I've only actually did this on the smaller instances, right? Because it's an interesting idea to try it on the larger instances to see if you get any benefit. But obviously, I did it on the smallest ones because you want to try to save cost. That's where you're doing that, right? It seems that this is the way their kernels are configured. What it has to do because UML is a kernel running on top of another kernel, basically. And if you don't do that, it just fails.
What kind of application
Okay, what we're doing, is we're dealing with with video, and we want to deliver like personalized video appliances, to users, which allow them to write applications as well. So this is why these kinds of virtual environments are important to us, and which is why we must also split them finer, to save costs and to isolate the users from each other. So that's what we're using EC2 for, is to create these kinds of environments, for just ordinary users, so they can have root access, to what appears to them to be their own machine. It's like, a virtual iPhone kind of thing, which is available every time, the internet is available in your browser. Yes, we do. We use S3 quite a bit. We're also trying out some other services, in similar vein, which have cheaper bandwidth. Amazon can get a little expensive, in that respect, if you're streaming video out of it.
Running server systems have been reliable in the earlier stage you mentioned crashes.
We found them to be, yes. Like we found them that they'll stay up for months. We didn't have any problems. Now, mind you, we don't do a lot of configuration on them. Like we start them up and we use them, right? I don't know. We don't do a lot of it. I've heard Pete, I think, say that he did quite a bit of interaction over the Amazon API with these things, and that caused it to fail. In our application, we don't do that as much. We basically start up the machine, configure it, and more or less, it's it works that way until it shuts down. So different logic path and apparently different result. But we found them to be reliable. I've never had one crash on me, for example.
I use them all the time. Never had a crash. It wasn't my fault. Has performance been a problem?
No, we don't generally find internally they're quite fast. To S3 they're quite fast. We've had some weird throttling happen, once or twice, but we've never determined, right away. We've never determined whether that was on Amazon's end, or on our end. It's possible that if they get overloaded, maybe they'll do that, right? But we've never concluded. It's generally fast and reliable. There is a caveat, of course, if the machine shuts down for any reason, you do lose that information. So you need some way. Either you're going to mount, NFS, and you're going to back up the NFS. Well, it doesn't matter anyways. You're going to back up the NFS into S3, for example, or elsewhere, or you're going to, use S3FS and perhaps debug it, so it's more reliable. But other than that, you will lose your data if it shuts down. Okay. By the way, is anybody interested in seeing demos in open space? So there's, if anybody's interested, feel free to talk to me and talk about it.